Welcome to the Explainer. Today, we're going to decode a really crucial C-sharp concept, one that can literally be the difference between a 5-minute fix and hours of pulling your hair out debugging. It's all about how your code communicates when things go wrong. So, let's just jump right in with a question that gets to the absolute heart of this. What if the error messages in your code got all messed up? Like in a game of broken telephone? How could you ever hope to find the real source of a problem? Look, in the wild world of software development, errors are just a fact of life. They're gonna happen. That's exactly why developers use this safety net called exception handling. It's how we gracefully manage and recover from those unexpected hiccups without the entire app just crashing and burning. And right at the heart of this safety net is the throw statement. You can think of it as the mechanism that officially raises a red flag and tells the rest of the program, hey, something's gone wrong over here and we need some help. Okay, so let's check out the first, and spoiler alert, the correct way to signal for help. This is where we use the simple throw command all by itself to sound the alarm. So what's it actually do? Well, simply put, throw sends an exception up what's known as the call stack. And you can just picture the call stack as a chain of command in your code. The throw statement passes the responsibility, along with all the critical details, to another piece of code that's been specifically set up to handle it. A really good way to think about this is like making a perfect 911 call. You report the problem clearly, and that message travels right up the chain of command, clean and intact, until it gets to the exact right person who knows how to deal with that specific situation. Now, here's the secret sauce. What makes this so incredibly effective is that it preserves the entire history, the full stack trace. A stack trace is basically a breadcrumb trail of every function that was called to get to this point. It gives a developer a perfect, crystal clear path showing exactly where the problem started. Okay, let's look at what this looks like in the code. Inside a catch block, after you've maybe logged the error or something, just using that simple throw all by itself is like passing the original, unaltered incident report right up the chain. You're rethrowing the original exception with all of that valuable context perfectly intact. All right, now for the other way of doing things, the one that causes that critical communication breakdown we've been talking about. This is the throw X pattern. Now, throw X looks almost exactly the same, but it does something completely different, and honestly, it's pretty destructive. It rethrows the exception, but in doing so, it completely throws away the original context. It basically creates a brand new exception right there on the spot, losing all the history of how the error actually started. Now, you might be thinking, hey, but what if I want to wrap the original error in a new, more specific exception type? And that's a great instinct, but throw X is absolutely the wrong way to do it. The correct way is to pass that original exception as an inner exception to the new one. That way, you preserve the full original context. And this is exactly like that game of broken telephone we mentioned. The message, the exception, gets passed along, but all the crucial information about where it really truly started is just gone. The person at the end of the line has no idea what the original message was. And the consequence of this? Oh, it's a total nightmare for debugging. Because that original stack trace is gone, it becomes incredibly difficult, sometimes almost impossible, for a developer to figure out the root cause of the error. The trail just goes cold. And this little bit of code just shows you how tiny, yet how disastrous the difference is. Just by adding that little X variable after the word throw, you've basically hit the shred button on the original error report. You've completely reset the error's history and broken the entire chain of evidence. So let's put these two side by side. Let's see how this really plays out for the poor developer who has to hunt down and fix this bug. And believe me, the difference is like night and day. Yeah, I mean, this table just lays it all out, doesn't it? With a simple throw, the stack trace is preserved, which makes debugging effective. You get a clear trail, the whole origin story. With throw X, that trace is lost, the story is obscured, and debugging becomes this massive challenge. It makes the recommendation pretty darn obvious, right? Always, always prefer throw. So, with that stark comparison in mind, what's the ultimate takeaway? What's the one golden rule you should follow to write code that's better, more maintainable, and a whole lot easier to debug? It all boils down to this. Just like in a real-world emergency, preserving the full context is everything. When you're handling exceptions, your number one priority should be to provide accurate, complete information to the next person down the line, which, let's be honest, is probably going to be you 6 months from now. So, the path to better debugging and much more robust software is actually pretty simple. 1. Always choose throw over throw X when you need to rethrow an exception. This makes sure you 2. Preserve the original stack trace so you can 3. Maintain a clear trail right back to the source of the problem. And that leaves us with one final thought to take away. This core principle, preserving context to prevent that broken telephone situation, it applies to so much more than just this one command. So the question is, where else in your work, whether it's in your comments, your documentation, or even just how you communicate with your team, where else can you apply this lesson to make everything that much clearer?